Hello, my name is Patrick Blevins, and today we will be talking about positive and negative selection of thymocytes. CD4 plus, CD8 plus, or DP thymocytes are small, non-proliferating cells that reside in the thymic cortex. They're the most abundant subpopulation in the thymus, and they are the first subpopulation of thymocytes that expresses a fully mature surface TCR alpha beta slash CD3 complex that are the primary targets of thymic selection. Thymic selection shapes the TCR repertoire of DP thymocytes based on the affinity of their T cell receptors for the MHC peptides they encounter as they browse the thymic cortex. Um, Thymic selection is necessary because the most distinctive property of mature T cells is that they recognize only foreign antigen combined with self MHC molecules. However, they do randomly generate the TCRs, or generated TCRs will certainly have no inherent affinity for foreign antigens plus self MHC molecules. They could just as well recognize foreign MHC peptide combinations, which would not be useful, or self MHC self peptide combinations, which could be dangerous. During this process, there's two distinct processes that are required. The first process is positive selection, which selects for those thymocytes bearing receptors capable of binding self MHC molecules, resulting in MHC restriction. MHC restriction can be defined as the characteristic of T cells that permits them to recognize antigen only after it is processed, and the resulting antigenic peptide is displayed in the association with either a class 1 or a class 2 MHC molecule. Differentiation of the alpha beta T cell receptor, or the TCR expressing T cells, involves a mandatory interaction with self major histocompatibility complex, or the MHC molecules, in the thymus. This process, which is called positive selection, both rescues thymocytes from programmed cell death and induces their differentiation into mature T cells. Positive selection, it requires that the alpha beta TCR recognizes self peptides bound to the MHC molecules displayed on the epithelial cells of the thymic cortex. If the TCR has a sufficient but not too high affinity for self peptide MHC complexes, then the thymocyte receives a signal allowing its survival. If that signal happens to be weak or just totally absent, then the thymocyte will die by apoptosis as a result of activation of capaces, which is a family of intercellular cytosine proteases. Too strong of a signal in the thymic cortex may also or may not result in effective positive selection. The second distinctive selection process is negative selection, which selects against thymocytes bearing high affinity receptors for self MHC peptide complexes, resulting in self tolerance. Self tolerance is just basically defined as being unresponsive to self antigens. Uh, Negative selection is a critical event in the thymic development. It prevents maturation of hazardous autoreactive T cells. Thus, mechanisms exist to eliminate T cells with self-reactive receptors. Positively selected CD4HI, CD8, and CD4 CD8HI thymocytes enter the medulla, where they undergo a second selection process called negative selection, in which they are eliminated by apoptosis if their TCR has too high of an affinity for self peptide MHC complexes expressed on the medullary DCs. Negative selection helps eliminate alpha beta T cells with TCRs that could pose a risk of autoimmune reactions, and is an important influence on the final TCR's repertoire. The thymic epithelial cells found in the medulla express a diverse array of tissue-specific antigens. Some examples would be like insulin or myelin basic protein, and that helps uh, in the elimination. Individual thymic medullary epithelial cells express only some of these self-antigen proteins, and this expression is acquired in an apparently stochastic manner. Positive selection ensures MHC restriction. If a CD4 plus CD8 plus thymocyte or DP thymocyte recognizes a self MHC peptide complex on the cortical epithelial cells that they browse, it will undergo positive selection. This process includes both survival and differentiation of the DP thymocytes. Uh, the majority of newly generated thymocytes do not successfully engage the MHC peptides they encounter with their TCRs. This happens because they either have not generated a functional TCR alpha beta combination, or the combination does not bind the MHC peptide complexes excuse excuse me with sufficient affinity. Ultimately, the cells have failed the positive selection test and will die by apoptosis within 3 to 4 days. The signal cascade produced by positive selecting TCR interactions has not yet been fully characterized, but we do know some things such as many of the signaling molecules required for positive selection are also involved in T cell mediated activation of mature T cells. Um, the adaptive value of positive selection is valuable. Some have suggested that paring down on the repertoire is important to increasing the efficiency of negative selection, as well as to increasing the efficiency of peripheral T cell responses. Without positive selection, the system would be cluttered with a great many cells that are unlikely to recognize anything, and it would reduce the probability that a T cell will find its antigen in a reasonable period of time. So it would slow everything down. Uh, Some others suggest that positive selection may also offer more subtle advantages that often inspire uh, discussion in the field. These are my references. Um, this had two. I used the book, and then I had one outside resource. And Dr. Blair, I'm fine with you using this video in your library or for further in future uses. Thank you.